This video is a follow-up to my previous video. Sometimes the task of comparing two structures can get tricky. For instance, you might determine that two structures are enantiomers, where in fact they are actually identical compounds. And conversely, you may find that two structures are identical, but in fact they are enantiomers. Let's take a look at an example to illustrate this. Let's look at problem 1b in assignment 5-2. First glance, these two structures may look like they're enantiomers. For example, the structure on the left, you have a carbonyl group at position 1, and then in position 2 and 3 you have methyl groups. And you have the same thing in structure on the right. Carbonyl group at 1 and then methyls at 2 and 3. And if you compare the two chirality centers for the two structures, it looks like the two chirality centers are reversed, and you then may conclude that these are enantiomers, whereas in fact that is incorrect. So in a case like this, what you want to do is to take one of the molecules, flip or rotate it so that the two can be directly compared, so that the two have their atoms in identical corresponding positions. So what I'm going to do is take the molecule on the right and flip it as indicated. There we go. Now we can compare the two. You can see that after flipping the molecule on the right, all the atoms are in the same and corresponding positions. And as you compare them, it's rather obvious that the two chirality centers are indeed identical. These two molecules will superimpose, and in fact they are identical. Let's look at problem K. When we compare the two at first glance, it looks like the two chirality centers here, it looks like they're like the second compound and the first, it looks like they are reversed. And so you might say that these are enantiomers. Well, you would be wrong. So let's do this. Let's take the molecule on the right and flip it as shown. And when I do that, it's rather obvious now that these are identical. They are the same compound. Also note something else about this. This compound with its two chirality centers, the two chirality centers are equivalent. This compound is actually a meso compound. It has as well, you see, a plane of symmetry. So you always want to look for that. You could have a molecule that's a meso compound in the first structure, and then it's flipped in the second so that they actually look different, but they're not. They're the same compound. To do another problem, this is problem I. As you compare these two, it may look like they are enantiomers. You can see the two chirality centers, it looks like they are reversed, but in fact that would be wrong. And when you're comparing these, we want to be able to see them in identical and corresponding positions. So we're going to do as we did before, we're going to take the molecule on the right and flip it as indicated. And when we do that, it's now rather obvious that these two structures are identical. This is the same compound. So the lesson is always be willing to flip, to rotate one of the structures so that you can better compare the two and determine if in fact they are identical or enantiomers. Thank you for watching.